Welcome to clickmyproject.com.
Now we discuss about the product for low power digital signal processor architecture for wireless sensor nodes. Next we see the abstract for the product. Wireless sensor network application range from medical monitoring to environmental sensing, industrial inspection and military surveillance. Wireless sensor networks node essential consist of sensor, a radio and a microcontroller combined with a limited power supply. Example for battery and energy serving. Since radio transmission are very expensive in terms of energy, they must be kept to a minimum in order to extend the node lifetime. The radio communications to computational energy cost range from 100 to 3000. So the data communication must be traded on the on-node data processing, which in turn can convert a many sensor range up to the wireless sensor networks. The wireless sensor network, we have shown the parallel prefix computation can be common demonstrated in of many wireless sensor network data processing algorithms. The goal of this paper design an ultra low power energy wireless sensor digital networks by further exploiting in the characteristics of unique to wireless sensor network. Radio communication exhibits the highest energy consumption in wireless sensor nodes, given their limited energy supply from batteries and servings. These nodes must trade data communication for on-node computation. Currently, they are designed around the self-low power microcontrollers, but by employing a more appropriate processing element, the energy consumption can be significantly reduced. This paper describes the design and implementation of a newly proposed folded tree architecture for on-the-node data processing in wireless sensor networks using the parallel prefix operation and the data locality in our hardware architecture. Next, we see the flow diagram for the product. Our wireless sensor network consists of each data processing elements. The processing element, everyone consider the each data path architecture. The data path architecture is similar to the ALU architecturing process. So the input data bits are applied to the selection mux architecture. Based on our selection process, we apply the input data into the register elements. The register elements is made up of the D flip-flop architectures. Thus, the D flip-flop register element architecture results are applied to the ALU process. The ALU process mainly considered for the 4 arithmetical process and 4 logical process. These logical blocks are applied to the mux selection process. The mux selection process to select the each and every results for the processing data element. Thus, the ALU results are applied to the mux and buffer architecture. The mux are selection the output data results and the buffer architecture for used to the some timing allocation elements. Then to connect the feedback output process based on our selection process, then the dry gate operations to mainly used for the our architecture processing elements. Thus the processing elements to mainly used for our the regular data path architecture results. Our architecture results mainly based on the selection process. Thus the selection, whatever the selection is applied to the data process, then to apply the and finally we apply the ALU architecture results and to calculate the simulation synthesis resulting process. Next we will see the final output for the product. First we open the Xilinx IC project for ALU low power architecture. Our ALU low power architecture was developed by VHDL language. This ISC project navigator is mainly used to do simulation and synthesis processing for our ALU processor. Then select the simulation process and select the main RTL functions to click the simulate behavioral model. Then to open the iSim simulation project list, this process mainly used to the simulation purpose. First we create the clock input signal for our process, then to apply the input data bits for our the ALU architecture results. Then the selection process is mainly given to the two input signal for the ALU architecture process. In ALU selection process, what are the output to display the our output results? Then the output selection list to apply the our architecture process. Then the feedback analysis to apply the sure. Then to apply the clocking signal for our the final output process. Then the final output are displayed by the required input signals. Then apply the then to close the simulation result and to create the implementation process. The implementation process mainly used to synthesis report and to create the RTL schematic diagram, then add and create the schematic. Then the ALU process are applied to the RTL diagrammatic representation. Our ALU process to create the what are the logical blocks placed in our architecture. Then to create the technology diagram, then add and create the schematic. Just we open the technological RTL representation. This RTL diagram is mainly technology diagram is mainly used to what are the lookup table and wire length and flip-flop pairs in applied to our ALU architecture process. Then to open the design summary process, just we create the synthesis report results and to open the synthesis report, then used to the device what are the device utilization in our ALU architecture, lookup table and flip-flop pairs, then the bounded input outputs. These results are used to the area for our process result, then to create the latency level for our the process. This process mainly used to the timing summary of ALU architecture process and to use the what are the before and after clock due to the running of each and every LUT functions in our ALU architecture process.